argue about scale, you might argue about importance of processes, but effectively the fundamental structure of climate models is now quite well established and quite well understood, and they do obey, our atmosphere and our ocean obey physical laws, whether we like it or not. That's the great advantage of them, that's the great disadvantage, that there really isn't much choice. For policymakers, this scientific knowledge has relatively little value, and what we're looking at is the way our climate science can be used in terms of policy and in terms of trying to inform about the way climate is going in the future. And this has obviously taken off over the last 20 years as concern over potential greenhouse gas climate change has taken place. So what's important now is not necessarily to predict into the future. The word to use is project, not predict. Models don't predict, they project according to a set of assumptions into the future. But to be able to evaluate critically what that prediction, in a sense of what the policymakers might see it as, they tend to see it as a prediction, just what sort of reliability we can put in that and how we can model that idea of that projection. And to do this, effectively, the general climate models, which is the sort of structures we've talked about previously, are forced. And the argument is very simple. What is potentially the most significant climate forcing mechanism is greenhouse gas emissions and greenhouse gas concentrations. Therefore, the simple way to do is to have your model of the Earth as we can understand it, our AOGCM, and force it by changing concentrations of greenhouse gases, which are radiatively active, i.e. they act upon incoming and outgoing solar radiation. So we can produce emissions, we can predict emissions or project emissions, but what we're not able to do is to predict human activity. So because of that, no single emission scenario can be produced. There is no single trajectory at this stage that we can have any confidence in whatsoever in terms of what effect that's going to have in terms of emissions. So if we're going to look at future climate scenarios which are forced by radioactive, by radiation, then the essence of that is that we have to hypothesize different scenarios of greenhouse gas emissions which are predicated largely and not entirely on fossil fuel emissions. So what we have are a series of emissions scenarios. And the IPCC based and sort of guided the idea of uniform emission scenarios, or SRES. They produced a special report on emission scenarios trying to look at the likely emissions or the likely possibilities of emissions that there are. This arose out of dissatisfaction with the earliest IPCC reports that forced climate according to rather straightforward, simple scenarios, of which the one that got criticised was the business as usual scenario. The sort of worst scenario was we just carry on, we just go on doing what we've been doing, we don't worry about it. And the BAU scenario was the sort of worst case scenario that came in. It was felt, as the IPCC process developed, that it was necessary to get a much better idea of the sort of scenarios that could play out, and we got therefore these IPCC scenarios, which effectively come out A1, A2, B2, sort of A's and B's. We'll go into these in some detail. But feeding in these are population, economy, technology, energy use, land use, agriculture, all the things that are in the control of human activity, that are controlled economically, that are controlled socially, that are controlled culturally, that are not controlled scientifically. None of these are scientific forcing factors. Population change, population rise has got nothing to do with science whatsoever. Well, it's partially to do with science in terms of things like birth control, etc. But that is nothing to the opportunity for controlling population is there, but whether people adopt it or not is another matter. So in fact it's a social, cultural issue. It's not, world population is not a scientific issue. Except in a sort of set ways like increasing longevity, for instance. The economy is, again, not a scientific, it's not scientifically driven. Scientific changes provide opportunities, but they're not what decides whether we have a growth economy, a stabilisation economy, a highly technological economy, or so that is within social and cultural domains. Technological change will obviously feature, and probably the biggest is, of course, our attitude to energy, and our attitude to different forms of energy and to energy use. And that's very unpredictable. Just witness Australia. I mean, Australia is now effectively back as a coal-guzzling. I was talking to somebody yesterday who said they've now decided that the only thing that held back some coal use in northeast Australia was not knowing where to dump the waste, but they've now decided to dump it on the Barrier Reef, because the government is effectively they don't give a toss, ultra conservative in terms of energy use, and that will mean more carbon, on all the other things. Now you might not have predicted that as a projection, but it's a scenario that therefore you have to account for. Land use change, of course, is significant. We'll talk about this, and agricultural change is also. But these effectively drive change economically and drive change at regional and global levels, which we can try and predict in some sort of scenario. So you will find on your sheet, is there any spare sheets behind you there? I just have one. What I've done on these is sort of, this is the printout of the emission scenarios and the details. I'm going into them in some detail, but I'll make sure you've got a copy of these. So the A1 solution is a storyline, effectively. They're narratives in good cultural geography terms. We're now talking narratives. Very hushed terms and very careful use of words and very long ones that mean nothing. So we're talking about rapid, and the narrative here is rapid, successful economic development. So the globe overall continues rapid economic growth and development. Regional average incomes per capita converge, i.e. the poorer countries are brought up. There is a convergence of economies, and the distinctions between rich and poor begin to dissolve. So in other words, it's a sort of slightly utopian view of economic development. It's market-driven, so there's a strong commitment to market-driven solutions, high commitment to education, therefore technological improvements are likely, high rates of investment and innovation, education, technology, etc., across all levels, mobility of ideas. So in other words, a world that is growing rapidly, but is also growing intellectually and technologically as well. Very successful economy, very successful world in many ways. There is, though, then that's the A1 scenario is then sort of subdivided according to the emphasis on fossil fuels. A1F1 is fossil fuel intensive, so that's Australia, China-ish. So in other words, that's a projection that suggests that despite all this technological change, we will still be very fossil fuel intensive. A modification of that is the A1B, which is one of the sort of chosen scenarios as a favoured scenario, as we'll see later on, where there is a move to balance alternative fuel sources and energy sources. In other words, there's a balance between renewable energy, nuclear, and fossil fuels. Again, if you take this country, we could have seen that we were, and then A1T, emphasis on non-fossil, i.e. to move to renewables. Now you could say that this country was, until a couple of years ago, possibly sort of flirting with this. There was definitely attempts to sort of move the economy to one which was more Euro-facing, which saw renewable energy, meeting renewable energy targets. With fracking, we've now probably gone back to this, and increasingly we're moving towards that again as wind energy is being stopped, as there's no investment or little investment in solar energy, and we're moving to revisit some nuclear, but effectively, you know, the UK, for instance, would be somewhere in here. But we're talking, these are sort of global scenarios, so we can see that the global scenario will depend on all the individual scenarios balancing up. But the one that A1B is the sort of one that tends to be used. The A2 scenario, so we have A1 scenario, and that's the sort of top end worst case scenario climatically in terms of radiative forcing, or certainly greenhouse gas emissions, as we'll see. A2 represents a differentiated world, less trade flow, relatively slow technological change, and we have a consolidation into a series of economic regions. So we still have rich and poor, we still have energy intensive and energy low intensive use as well between the different parts of the globe. Far more self-reliance, less interaction between regions, uneven economic growth. If anything, the difference between rich and poor stays fairly similar to what we actually see now. So in other words, not everybody develops. Not everybody develops rapidly. But B1 scenario, world with a high level of environmental and social consciousness and a more globally coherent approach to a sustainable development. With technological change, despite the fact that there's still variability between, despite the fact the investment in technology at a global sense is perhaps not as much as in A1, but there's also a commitment to alternative fuel and to technological change playing a different role. Instead of sort of technological change making oil more accessible from under the Arctic Ocean, it's technological change that makes solar power more usable, more efficient. So it's a commitment to a different sort of energy use. Economic development is balanced, still doesn't necessarily so we still got this balance between richer and poorer,